Good morning. Today we're going to look at the sum of the angles in a triangle. So if we have angle 1, 2, and 3, we add those all together with the angle addition postulate, we can see that they're going to equal 180. So we also can see with this picture that these three angles have a sum of 180 degrees. So we're going to prove that here. So we know that this is a triangle with vertices A, B, C, and through any point not on the line, there's going to be one line parallel to the given line. So line AB will be parallel to line, and we'll say this is D, C, D, because we need 2 points for a line. Now looking at the angles, these three angles, 3, 4, and 5, are going to add up to equal 180 degrees. That's using the angle addition postulate. Now if we look at some of these transversals, we can see that angle 1 is congruent to angle 4. And another transversal, angle 2 is congruent to angle 5. Now using the definition of congruence, we know that the measure of angle 1 will equal the measure of angle 4, and the measure of angle 2 will equal the measure of angle 5. So we can use some substitution. So I can plug in measure of angle 1, where I see 4, and substitute angle 5 with the measure of angle 2. So we've proven that the sum of the angles in a triangle equal 180 degrees. Now let's use that information to find these variables. So here we have a linear pair, so we know y plus 78 equals 180. So if I subtract 78 from both sides, y will equal 102 degrees. If I look at this triangle here, well, we know those three angles, x, 32, and 78, will add up to equal 180. So if we subtract 110 from both sides, x will equal 70 degrees. So we use that triangle sum to find the value of x. The second theorem I want to cover today is the triangle exterior angle theorem. Now looking at this triangle, we have interior angles. These are called the two remote interior angles. Well, we know all three of the interior angles will equal 180, but we also know if we extend this line to include the exterior angle, these two angles, the linear pair will also equal 180. So we know that the angles 30 plus 90 have to equal 120, which is the exterior angles theorem. Now let's use the exterior angles theorem to find the missing angle measure. So this is the exterior angle, 1, and it's going to equal the sum of 45 and 75. So the measure of angle 1 has to equal 120 degrees. In the second example, the measure of angle 2 and 51 have to equal the exterior angle. If I subtract 51 from both sides, the measure of angle 2 equals 58 degrees. So we use the exterior angle theorem to solve for those variables. The last example is a little bit more complicated, but we have these parallel lines here. So we can see right away with the transversal that the measure of angle 2 has to equal 55 degrees. Now I'm just going to look at the triangle here formed with angles 1 and angle 2. So we figured out the angle 2 equals 55. And we can figure out this second angle because it has a linear pair. So if that angle is 75, then the linear pair at that angle must be 105. So the measure of angle 1 plus 55 plus 105 has to equal 180. So these two add up to 160. So the measure of angle 1 must be 20 degrees. Now let's look at the third angle. So these are all going to add up to 90 degrees because we have two lines that are perpendicular. So the measure of angle 1 plus the measure of angle 3 plus 55 equals 90. So remember, we just figured out angle 1, so that equals 75. So the measure of angle 3 must equal 15 degrees. So we use all those triangle theorems to solve for angles 1, 2, and 3. The two angle theorems that we covered today, interior angles, the sum of them equals 180, and the exterior angle measure, which is the sum of the two remote interior angles.